What comes in the control.Node Sense and Control Kit, and how do you use Blockly code and the engineering design process to make the components work? The Sense and Control Kit comes with a control node and a code node, which are the devices that handle input and output commands specified by your code. The kit also comes with a servo that connects via the servo ports of the control node, and a high-speed stepper that connects via the power output ports. Additionally, the kit includes a fan, which is powered through the USB plugs on the power output board. To really get into some engineering challenges, the kit also includes a light bulb and stand, connecting wires, a pulley, a motor bracket, one set of mounting screws for the motors, a Phillips screwdriver, string, and a house and meter template, as well as some rubber bands and paper clips. I've already connected the control node through the sensor data option in SparkView, but these activities can also be done in Pasco Capstone software. So as you can see, the control node has several onboard sensors, but for now I'm going to disable those and select the line graph display. We'll come back to the line graph display shortly, but for now let's get into some coding. You see this puzzle piece down here? That is going to take you to the Blockly code screen. From here I can select hardware, and I'm going to pull out the control.Node speaker. You can set the frequency of the speaker from 0 to 20,000 Hertz. For this demo, let's set it at 4,000. When I click execute, you should hear a quick chirp. Let's try that again. All right, so what if you want the speaker to be on longer than a quick second? I am going to use a time block to extend it. Right now it's set for 20 milliseconds. You can also select to program in seconds. So let's see about having the speaker run for 3 whole seconds. All right. But what if you want the speaker to keep going until you stop running the program? For this, I'm going to need to add an infinite loop. So I'm going to go to my loop section and pull out a repeat while true. Now that I have my infinite loop, I can delete the sleep block and pull the speaker into the loop. All right, so now you've seen a quick and easy way to program the speaker on the control node, but let's try pulling in some real-time data into our program. For this, I'm going to go and disable my code for now and select the code puzzle piece. I turned on my code node, but I need to connect it, so I'm going to click on the Bluetooth icon so I can connect. Now that my code node is connected, I can select the measurement I want to use in my program. I am going to choose brightness. So the code node has a light sensor built in on it. Let's see how it works. I'm going to start recording data, and as I put my finger over the light sensor, you see that the data quickly decreases. So the brightness is around 6.5 right now, and when I cover the light sensor, it drops down to almost 2%, maybe 1.8. That's going to be some important information for my coding program. I'm going to go back to the puzzle piece and come back to Blockly and enable my code again. So what I'd like to do is create a program when the light sensor goes below a certain percentage, it's going to trigger the speaker to come on. For this, I'm going to select a logic block and create a condition statement. So if the brightness, and you'll notice right now this says temperature because the code node has a temperature sensor, a brightness and loudness sensor in it, but I want to toggle down and select brightness. let's switch back to the data view. And I'm going to say when the brightness gets below 3%, I would like the speaker to turn on. I need to select a math block and say when the brightness is less than 3. I want my speaker to turn on. Well, I don't want it to stay on. I want it to turn off when I release my finger and the brightness increases again. So I'm going to include an else statement now. There's a couple ways you can add the block here. You can either right-click to duplicate, and then I can set the hertz to 0. But we also have a block included in Blockly to where you could turn the control.Node speaker to true, which is on, or to false, which is off. All right, let's see how we did. And we have success. Excellent. So you just saw how we can include real-time data in our program to trigger something to occur. But let's make it a little bit more interesting and show you how you can use some of the components that come with the kit. So now, this is what I'm going to do. I am going to go ahead and leave this code for a second, and I'm going to connect my power output board to port A on my control node. I've already connected the connecting wires via the terminal plugs, and I have the light bulb in the holder. So what I'd like to do now is when the brightness goes below a certain percent, rather than the control node speaker going, I would like the light bulb to turn on. To do that, I'm going to delete the speaker blocks, go back into hardware, and now I'm going to select the power output block. Now, right now, it says that my power output is connected into port A, which it is. And right now, it's saying that I'm using the USB. I want to use the terminal pins here. So to do that, I'm going to toggle from USB to terminal. And now it's giving me a power value, which you can program from 0 to 100%. I want the light bulb to be pretty bright, so I'm going to go ahead and set it at 100% power. Right-click, duplicate, pull in that other block, and I'm going to set this to 0, so no power. All right, let's see how we did on this one. Click Start, cover my light sensor, and that light bulb comes on. And what's interesting is you can set this power value at different ranges so you can adjust the brightness of that bulb yourself. There are endless engineering projects that you can do using the control.Node Sense and Control Kit. I'm sure your brain is already spinning with possibilities. Visit pasco.com to access lessons, and you can also access resources from the product page. Thank you for taking the time to join us and have fun digging into coding and engineering design.